Okay, so let's take a look at CSMA CA and RTS CTS. So these are both protocols at the link layer in our TCP/IP stack and help us avoid collisions in congested networks. Now CSMA CA stands for Carrier Sense Multiple Access with Collision Avoidance. And it gets this name because the carrier refers to our devices on our network, and the sense refers to them sensing each other because they are both transmitting radio waves, which is Wi-Fi. And the multiple access comes from they can both be on the same network, and then we have collision avoidance. So CSMA are when devices sense each other to avoid collisions. Now RTS, CTS stand for request to send and clear to send. And these are designed to further prevent collisions by devices sending requests to send, RTS, and then a router, say here, saying, right, you are clear to send. So let's first take a look at why we even need collision avoidance algorithms. So you have a router here called R. You also have device A, which is over here, such as your phone, and you have device B here. Now, the range of the router is going to be a certain defined thing. So it could be this, which encapsulates both A and B. However, the range of A may only be this. And the range of B may be this. And so what have we got here? So this is talking about if A were to send out radio waves, say Wi-Fi, it would only be able to reach within this circle. And the same with B. So in other words, B and A cannot reach each other. Now, for simplicity, I'm going to write it like this. Now, here's where collisions come into play. So if A were to send a packet at the exact time that B were to send a packet, remember what a router actually looks like is obviously we have our router, but then inside of our router or outside are these antennas, and the antennas are what actually receive the signal. So if an antenna was to receive both A and B at the same time, which is what's happening right now, if we were to see what that antenna captured, it would look something like this. It would see B's radio waves, which is B's data, and it would see A's radio waves, which is A's data, which means that the router is not able to actually read the data and process the data. So in other words, A radio waves have collided with B radio waves. So this is where we need collision avoidance algorithms to help us not make the data from different devices come in at the same time so the router is able to read them effectively. And for reference, this is known as the hidden node problem, where two devices, A and B, which are known as nodes, cannot see each other. They're out of each other's radio wave ranges. And this is what leads to collisions at the router. So now let's take a look at how CSMA-CA helps us with avoiding collisions when our nodes are within range of one another. It does not help us in this scenario. So let's take a look at this. So C is an additional node or device. Now A and C are both within range on one another. However, the issue still arises. If C was to send to R and A was to send to R at the exact same time, the router, the antenna, would see both of their radio waves, so would not be able to process the data. However, we can use CSMA-CA to help us. So the way CSMA-CA works is, say, device A listens to see if the channel is busy. So it can scan the network. So this device, like your phone, can scan other radio waves here. So C's radio waves are sort of like this. And it can see if C is sending anything. So let's say C is not sending anything. Because the network is free and there are no radio waves, in other words, C is not transmitting to R, device A can now send to device R, like this. And R will be able to see device A's radio waves. And now let's say C wants to send, well, because we're using CSMA, carrier sense multiple access collision avoidance, C is going to sense that A is sending to R. So C will wait until R is finished. Then once R has finished sending, C will send if the network is free. And now R can read C's data. So as you can see here, this is how CSMA-CA helps us, but only if our nodes are within range of one another. They can sense each other. Let's take a look at how CSMA-CA does not help us with the hidden node problem. So let's say A senses to see if the network is free, which it is. There are no radio waves being transmitted within A's range right now. So A sends to R. And now B does the same. B does a sense to see if there are any radio waves being sent in B's network or B's range, and there aren't, as we can see. So B sends. However, the router then sees this. It sees both radio waves. So unfortunately, the data becomes corrupted because the router cannot distinguish the actual contents of their data. And what is the root cause of this? The root cause is this hidden node problem, as we said. A and B cannot sense each other because their ranges are too far apart. So let's see now how RTS, CTS help us with the hidden node problem even when our nodes and devices are out of range of one another. So let's say A wants to send to R. It first does our CSMA-CA by checking and sensing if there are any other radio waves sending to the router right now, which there are not. C is not sending anything. So A does not send the data initially. It sends what's called an RTS, a request to send. So now that the router has received this RTS by A, the router is going to broadcast a clear to send to all devices within its range. And take a look at this. The router has a very, very far range. So the router is going to send a clear to send to A. And this is going to give A the go-ahead. It's going to send a clear to send to C, but it's going to give it a time to wait. So it might say, wait 5 seconds. And R, the router, is going to send a clear to send to B and say, wait 5 seconds again. So now, as you can see, C and B are going to wait before sending, which will enable A to send the data it wants to R. And now R will receive A's radio waves and data. Then and only then, after the 5 seconds has arisen, can other devices send what they need to. And now if device B wants to send, B can do the CSMA-CA and say, okay, is there any devices sending within my range? No, there's not. So I'm going to send the request to send. to router. Router is going to say, okay, no other devices are transmitting right now, so it's clear to send B. You have the go-ahead, tick. And then devices A and C are going to get the clear to send, but they're going to have to wait 5 seconds to allow B to send the data. And this is the core difference between CSMA CA and RTS CTS. CSMA CA help us with this. It helps us avoid collisions when devices are within range of one another. So when devices A and C, as an example, can sense each other. However, it does not help us with the hidden node problem where A and B are out of range of one another, so cannot sense each other, which is why then we use RTS CTS, which uses the router to help us.